Hello everyone, this is day 11 of the Data Science Bootcamp. In the last lecture, we finished learning about SQL. We did practice on it, and in the next lecture, we will continue with probability. But continue, we'll get started with probability. Okay. First, I'll start with why probability is needed. Anything, anything that we do that has a probable chance, let's say it's a coin toss or anything in life, let's say there is a probable chance. You're never sure like if this will happen unless and until there is a outcome that has already happened in past and somebody is asking you, then you're sure that this has happened. That is hindsight. But when there's a probability, you make prediction. And we as data scientists, this is one of the thing that we will work on is making predictions. And how accurate is our prediction? Probability does help in that. Let's say there's an outcome. Let's take an example of coin. Coin has two sides, which is heads and tails. There is a 50-50 chance that it will be either head or tail. Okay. Is there a way you can increase the chance? No, right? Because let's say when you're doing probability, when you're doing any heads and tail, let's say you're counting it one by one. There's one time head, then there's one time tail. The answer may not be zero point 0.5 exactly, which is half, 50% chance. But when you do it till infinity, the probability does come to zero point 0.5. In derivation integration also, you do limits tends to infinity, and then you do it with an assumption that we are doing it for infinity. Okay, now how that helps in data science? In order to understand an outcome, you first make a theory like this. Can I increase the probability? Let's take an example. I mean, we are building an e-commerce site and there are 10 products. Okay. And out of which only one product is getting sold. Okay. So a random user coming and picking a product is 1 by 10. There are 10 products. One is a favorable outcome. We are going with an assumption that they will only buy one product. If we go with a cart value, then they may select all the 10 products or 3 products or 4 products. But for simplicity, let's assume they'll be only selecting one product. Now, what you want, let's say there is a hero product which is getting sold more, but all your 9 products are not getting sold. So it's your responsibility to figure out like why the hero product is getting sold more and how you can increase the probability of the other products as well. So I'm giving you a real world scenario in a very simplified version. Let's say there's another, let's again take example of an e-commerce site which sells beauty product. There is one packet, one face cream that gets sold more because it has a certain ingredient. Okay. So whenever, let's say, because in that label, that ingredient is mentioned, and if you start mentioning the same ingredient in all the product in some or the other way, let's say niacinamide is something which is very trending. A data scientist only must have figured out that this is a trending keyword. If you put it in a face wash, there is a very high chance that people are going to buy it. Okay. So you increase the probability of buying the product. So that is how you do it. So your responsibility is to increase the probability of the product that the users are buying. This is the scenario that you are a data scientist at an e-commerce platform. Okay, cool. So let's just get started. I'll start with simple definition. This is going to be a very short lecture. I'll try to wrap it up in an hour. And in next lecture, we'll start with hands-on machine learning. Okay, can you see my screen?
Yeah.
Okay, now what is a probability? Probability is a measure of the likelihood that a particular event will occur. It ranges from 0 to 1. Probability is used to model uncertainty with data, make informed decision based on the uncertainty. Okay, got it? We are making a prediction. We are understanding like what would be the output. So the formula to get the probability is number of favorable outcome divided by total number of outcome. A coin can have only heads or tails. So that is 2. And out of it, the favorable outcome will be 1. So that is 1 by 2. So 50% probability. Now, what is the role of probability in data science? Probability forms the foundation of statistical inference, machine learning, and decision making under uncertainty. Data scientist is used to estimate unknown values from the sample data, evaluate risk and uncertainties, make prediction using probabilistic model. So right now we are understanding the basic, but there are a lot of libraries which are available, which will sort of feed data. You have to just give them data and they'll give you a certain probability. Like this is the probability, this is that. So you won't have to do all the calculation from scratch. Okay, types of probability. One is a theoretical probability. Again, the coin example is the best example because it is very easy to understand. Probability of getting heads in a pair coin is 0.5. Okay, empirical, which is experimental probability based on observed data. Probability that the user clicks on ad based on 10,000 impressions That is an experimental probability. You are running an ad on Instagram and there are 10 people clicking on it. So favorable outcome is 10 and there were 10,000 views. So that is 10 divided by 10,000. So this is an experimental probability. Now this is more certain. Ideally, then you have a statistic that only 0.1%, which is let's say 10 out of 10,000 is 0.10 into 10 raised to minus 3 is the probability. So if you want, let's say, more number of users, so you create a batch of 10,000 this much, 20,000 this much. So that will help you create a calculation. Okay. Now key concepts are sample space, which is possible outcomes, and a subset of sample space, one or more outcomes. I'll explain it going further. Let's say example of a rolling dice. The sample spaces, it can only have 1, 2, 3, 4, 5, 6. These are the possible outcomes. And the event is possible probability of having it an even number. There are only 3 even number out of 6 dices, which is 2, 4, 6. So that would be 3 divided by 6, again half. There is a 50% chance that when you're rolling a dice, it will be an even number or an odd number. Real world business scenarios, predicting customer conversion rate from marketing campaign. See, this is one of the very important aspect, customer conversion rate. Everybody sees your ad. This is very related to digital marketing. Let's say I'm creating a advertisement and not a lot of people are clicking it. The only metrics I have is clicking on the website if they are coming to the website. So this is a very important metrics to understand, that how is the conversion rate in a marketing strategy. Let's say you are making a very good reel, but if they are not coming to your website, then it is of no use. So real world case scenario, there's a probability. And once you have a proper matrix, let's say last time when the reel line, there was a probability that 0.1 probability that people are coming to my website. In order to increase the efficiency, you want to get it to 0.2. Then that is your matrix that I'll make better reel. So my matrix increases from 0.1 to 0.2. Estimating product failure rate in manufacturing, calculating insurance ring, detecting fraud in financial transactions. All of these are real world scenarios. Now, how do you calculate probability? Very simple formula. Number of favorable outcomes divided by total number of outcomes. Okay, got it. I went through it again and again. And let's take example. Like if you roll a die, the probability of rolling 3 is, which is 1 by 6. Got it? Okay. Now, let's come to some questions. What is the probability of rolling a 5 on a pair 6-sided die? So anybody, it's an easy question. What is the probability of getting 5 in a die?
1 by 6 only, I guess.
Yeah, of course, 1 by 6. There's only 5 will be an outcome and there are total number of outcomes. So 1 divided by 6, that is 1 by 6. Now, here comes another question. 2 fair 6-sided dice are rolled. What is the probability that at least one of the dice shows a 4? How would you calculate that? Any idea, anybody? There are 2 dices. That's a catch. What would be the sample
11
space?
by 36.
11 by 36. 2 pairs are, what is the probability that at least one of the dice is 4? Okay, how did you calculate it?
Once we throw the 2 dice, we will get 1, 1, 1, 2, 1, 3, as well as we will got 36 outcome total. So sample will be 36. And we want at least 1 4, matlab 1 4 2 4 3 4 4 1 4 2 4 2 वो और 5 4 और 6 4, मतलब वो टोटल 11 हो जाएगा.
पक्का 1 4 4 4 1 4 2 4 3 4 1 7 by 36 नहीं आएगा क्या?
नहीं 4 वाला पूरा रहेगा ना. 4 1 4 2 4 3 4 5 4 4 4 6, मतलब वो 6 हो
कितने
गया
हुए?
ना. वो 6 हो
6
गए.
हुए. So 6 by 36. हाँ
1 4 आएगा, फिर
1 4
2 4 आएगा, 3 4 आएगा और 5 4 आएगा और 6 4 आएगा ना.
अच्छा, ये स्वैप भी कर दिया.
हाँ, स्वैप
Okay.
भी कर सकते हैं.
So got it. So that is a probability, that is 11 by 36. You calculated in your head. Nice. Okay. Homework practice. Okay. List 3 real world problems in data science where probability is involved. If you can think of any 3 real world problems where data science probability is involved. Devesh, if you can give me an example.
Spam detection.
Spam detection, yeah, that is one of the case. Nishant, if you can think of any. It could be, um, I think we went through marketing campaigns, we went through
Mhm.
spam detection. Fraud detection is one of the thing the
Got it.
probability can be used. Or yeah, we came up with three examples. Cool. Let's move to the next section. We have different type of probability. Just give me 1 second. So all of you guys are familiar with at least basics of probability, right?
Yeah.
Yes.
Okay. So I'll try to just go to few questions. Now let's solve a question, which is, let's say there is a card, and I'll write it down on the screen. Okay. A standard deck contains 52 cards. Okay. Now, question one, what is the probability of getting uh, a red color card? Okay. What would be the answer to this?
26 by 52.
Sorry, what?
Yeah. 26 by 52.
26
26
by
by 52. Correct. There are red color 26. Okay. Now, probability of getting a face card.
4
12
into
by
4.
52.
Uh,
Let's see.
King, Queen, J, and A is also a face card. So there are four in each color. 4 for
By
16.
16. 16.
16 by 52. Probability of getting a face card is,
face card mean you the that show a picture.
Mhm.
yeah, E is also considered as face card if you don't take it that way. At least we are here to clear the concept. So if
Okay.
at least, let's say if you are taking 4, then it is 4 into 4, that is 16 by 52. Getting a red color, because there are two red colors, which is diamond and heart, that will be 26 divided by 52. Okay, realistically speaking, you can like do calculation in your head, which will be 13. That would be how much? 13 into 2, 26 into 2. So that would be, what would be the outcome? Anybody? 1 by 5, right? Half. Oh, sorry, 1 by 2, half. 50% probability it is going to be red color card.
Hmm.
Okay, let's think of something. Now, if we take a unique card, let's say which is red of heart, queen of heart, that has to be 1 by 52, which will be 1 by 52. Okay, now how do we calculate sample space? Okay, now there are, let's say, two coins. Sorry, my bad. Let's say there are two coins. What would be the sample space for this? What are the total number of outcomes that can happen?
4.
Let's go via the outcome. Like, is it going to be head,
Head,
head, right?
Head, tails.
Head,
head,
tail, then
tail,
Tail,
head,
head,
tail,
tail.
head, then tail, tail. That
tail.
is four total number of outcomes. Now, if I increase to three coins, it is going to be a lot. We will not type it out. So the formula for that would be 2 raised to n. Can't do a raised to.
Raised
What's the caret sign? Not
to,
something I
6
just
number.
keep on. Yep, got it. 2 raised to n for coins. Now, if you do it for cards, what would be the formula for that? Number of cards, which would be 52 raised to n. Again, caret
Hmm.
n. That will be number of cards. So whenever you want to find a sample space, this is a very simple formula that, let's say, number of space. If there's a one set of card, you do a raise to one. There's a two set of card, you do the raise to 10. So sample space is very important to understand what are total possible of favorable outcome. Okay. In my case, whenever I did, sample space was not a problem because we do it on a 2D data. So we always have the total number of outcome. Let's say it is total number of products or whatever it is. We always have it is clicks by views or in my case it would be conversion by views. So we always have sample space, but there are cases where you have to calculate the sample space. Okay. Let's quickly jump to the next one. Okay. Now I have questions for you guys. Let's solve it together. My screen is visible, right? Shall I zoom it? I think I should.
Yes,
Better, right?
visible. Yes.
Just close it. I will put it down here. And these are the questions. Okay. You roll a fair-sided dice. You roll a fair-sided six-sided die. What is the probability of getting even number? We already solved it. Two coins are tossed. Find the sample space associated with this random experiment. We already solved it. Two-sided dice are rolled. What is the probability that the sum is 7? Okay. How are we going to go about it? There are two-sided dice. The sum of the outcome should be 7. So
Hmm.
what would be the sample space?
36.
36, right? Two dice
Hmm.
will be 6 raised to n. 6 carat n is equal to 36. Now, sum of 7. Like what are the probability of getting 7?
1 6.
1, 6.
One
Okay.
six two five
Yep. I think I'll just do, this will be easier to write. 1, 6, 2, 5,
3 4
3 4.
3, 4,
4 3
4, 3,
5
5,
2
2,
1 6.
5, 2, 6, 1.
6.
6 1.
Are we good? 1, 2, 3, 4, 5, 6. Again, it's 6 by 36. Easy, easy, easy. Okay. A bag contains 3 red ball, 2 blue ball, 5 green ball. What is the probability of randomly selecting a red ball? What is the probability?
3 by 10.
3 by 10. Excellent. Okay. What is the probability of randomly selecting blue ball? Would be 2 by 10. How come? Total number of favorable outcome is 3 plus 2 plus 5, and the possible outcome is 2. Cool. And the fifth number also we saw, getting a heart, getting a face card. Okay. What is the probability of getting a heart?
13 by 52.
Which is 1 by 4, I believe.
Yes.
Okay. Getting a face card. I mean, assuming there are 4 face cards. We already did it, which is 16 by 52. I think we can simplify it. That would be 8 by 26. I think 4 by 13. I don't think we can simplify more than that. Cool. Okay. Let's quickly move to the next one. This will be a sort of revision for you guys.
Hmm.
Okay. Now, in a probability, understanding basic definition is crucial for grasping more complex concepts. Here is the experiment that we are doing, an action or the process that leads to one or more outcomes. Example, rolling a dice. Deterministic experiment have predictable outcomes, while probabilistic or random experiment have uncertain outcome. So in deterministic experiment, have a predictable outcome. Now, how does how does that check? I'll give an example. Let's say somebody is asking you like what has happened in the past. Basically, if you had breakfast or not, so that you have the data feed in on your system that you had breakfast and what was the breakfast, you will be able to give a deterministic answer that I had this particular breakfast. So probability of answering that is 100%, considering you are in your, I mean, your brain is working fine, so you would be able to do it. So these are deterministic outcome. And whereas there are chances when we do a probability outcome. You might also be seeing the win percentage that happens in the cricket. How that data comes, can anybody sort of like think of like how those data come? That's a win percentage of a team is 8%, win percent of a team is 90%.
Based on several factors, I guess,
Hmm.
like
What are the factors?
wickets in hand, overs remaining. Or
Okay, but how do that happen? I mean, is it based on the historical data, let's say in past when there were 44 overs spared and 5 wickets were remaining and a run rate was less than 6, then 80% of team won. Like, do you think that would be the case?
that could be a case.
Okay. So
I
what we are
guess
dealing with, yes,
DLS
Nishan?
method was also considered.
I don't think so, but maybe it is considered because we don't have foolproof planning for that, I mean, formula for that. But let's go with the assumption. Like, how is that calculated? For that, sample space is very important. What are the factors involved? Let's come up with factors for that. As a data scientist, we have to think of this. What are the factors that could be involved? Let's say 100 matches happened in past, and whenever the team reached on a 44th over, if that run rate was less than 7, and if 4 wicket fall out of 100, let's say 80 matches were won by the the batting team. So that is how the probabilities are calculated. We are not putting a lot of factors here. We are, let's say, let's say they are also adding factors such as
Ground, like on this ground.
ground
Okay.
dimensions,
Yeah.
something the
Betting.
next batsman strike rate, or let's say let's increase the sample space even more. See, more the sample spaces, the more accurate the data would be. Let's say after 4 wicket down, Indian batting lineup had three left-handers, and Mitchell Stark is one of the bowler who has 5 overs left. So you can use those data as well. That Mitchell Stark is very good against left-arm pacers. So you add those data and then you come up with probability. And maybe you see there are right-handed batsmen and Mitchell Stark is not good with right-handed batsmen. So you use those data and you say the probability is more. So sample space is very important to get a possible outcome. Okay, and it will keep on improving. Whenever you develop an algorithm, this will keep on improving. Dices and coins, you can easily figure out like these are the dices, these are the coins. When it comes to real world scenario, you will either miss some sample data and that will sort of hinder your algorithm. So you have to be very smart about that. Okay, there's an experiment outcome. Probability, a measure of likelihood that an event will occur ranging from zero, impossible event, it is not going to occur. And then there is an event certain that it is definitely going to occur. Okay. Then there is a probability of event or B occurring. Now there are two events that are occurring. If you want to do a union, then there is an AND event or event occurring. Okay. Probability of event A and event B occurring together, both events occurring, that is an intersection. There are formulas to calculate this. Cool. The sample space set of all possible outcomes of an experiment event, a subset of sample space. Let's say there are favorable events that you want to check, and those would be events. Now, mutually exclusive events, two events that can occur at the same time. Okay, rolling a two die and rolling a five die can occur at the same time. Again, dice and coins are very simple example. But let's think of an example which are mutually exclusive events where two events can occur at the same time. Anybody? Devesh, if you can come up with example. Nishant, Krish, anybody? Which are mutually exclusive events. Both events can happen together. Let's take an example of, mm, I think cricket is your family. Just give me an example of mutually exclusive event happening in cricket. That will affect your probability. Again, we are building the win percentage. Okay. What are the mutually exclusive event that can occur?
Like in cricket.
Yeah, let's take an example of cricket because we're building the win percentage. We're adding sample space and all that. Two events occurring. Even I can't think of an example in cricket where mutually exclusive events are falling.
Hmm.
Okay, two events that cannot occur at the same time. Okay, two events that cannot occur at the same time. I think
when we
batsmen. Yes, there is.
toss the coin, so at a time only head will come or tail will come. Like same time head and tail never.
Yeah, exactly. That is an example of mutually exclusive event. But in terms of cricket, we are building a win percentage system. Now we want to come up with mutually exclusive event that two events that cannot occur at the same time. Let's say hitting a six and taking a wicket will not occur at the same ball. But how is that affecting our win percentage? I'm not able to sort of put it there. Okay. Again, independent events, two events where the occurrence of one does not affect the other. Again, let's say which are independent events. So I mean, I eating food is not affecting you, or you not eating food is not affecting me. So these are independent events, and there is a probability of, let's say, in past, in last 1 month, I have had my lunch for let's say 80% of time, and in next month, I'm going to have it 80% time, considering there was an average of 80% of me having lunch. That's the probability. Now your probability is different of having lunch. These are very independent events. None of it is. It's not like you wait for me to have lunch or I wait for you to have lunch. So this is one of the example of independent events. Let's take an example again in cricket. Let's think of an example which are independent events. Come on. Two events that occur, one does not affect the other event. Two events where the occurrence of one does not affect the other event.
So in terms of cricket, or
Let's take any example. In cricket can be a bit difficult to come with example. Any independent example in a probability.
like we can have two events of rolling a dice and playing cards.
They are not even related. Two events are not where the occurrence of one does not affect. See, if there's a one, it is not going to affect that next is going to be a one as well. These are like independent events, so they are not affecting them. In terms of cricket, if I put it, two events where the occurrence of one does not affect the occurrence of event, let's say probability of a bowler taking a wicket does not affect the probability of other bowler taking a wicket. It does affect sometimes, like a bowler is creating a pressure, so other bowler batsmen start playing with more cautiously, so that can help it. And yeah, let's take an example. Team Australia takes a wicket on 44th over, but that is not affect. That does not mean that whenever Team India will bowl on the 44th over, they'll take a wicket. So let's take it as an independent event. So these are not dependent on each other. Now, how do you calculate? These are the formulas. How do you calculate? This is an intersection event. There are two events happening. You want to find an what do I say, similarity between. So in order to do an intersection, the multiplication is the approach, okay, of an event, and you get a probability. Like this is a probability. Now there is a certain event, an event that is guaranteed to happen with a probability of one. It's like Virat Kohli scoring a century in the year 2016. So that was a very certain event. Okay, so I mean, just kidding. That was not a certain event. Okay, so these are the certain event you get to know. An impossible event, which is Karun Nair crossing 50 after scoring 300, which is an impossible event. So that's not happening in international cricket. And so that's an impossible one. I mean, that's not a very, what do I say, apt example. But let's take an impossible event. A number 11 scoring 100 is an impossible event. It has never happened. If you take a historical data, never happened. If that happens, then at the start of the inning, when a number 11 plays, it will be 0%. And it is only going to be, I mean, it is impossible event. So as per our data, it will not happen. But if they score it century, then our data will definitely change. Exhaustive event, a set of events that cover the entire sample space, meaning at least one of them must occur. Okay. Let's say there is a only two probability. Let's say we do head and tail. One coin, it can only have head and tail, and in the first it had head and second it had tail. So that's your exhaustive event. All the events have been covered which were in your sample space. Cool. So these are the definition that you have it in mind. So anyways, while calculating probability, you would be using frameworks to get them. And this will help you also understand at least you have the basic knowledge of probability. And I believe you guys might have basic knowledge, but this is just a refresher for you. Okay. Again, the complement rule. Okay. Again, complement rule is win percent is a complement rule. If chances of India winning against Australia is 84%, what is the chance of losing? What is the chance of Australia winning? That is a complement event. Complement event, my bad. It is 1 minus whatever. In win percentage shows in 100%. So if 80% is the winning chance, 16% is that Australia will win the chance. Okay. They used to calculate addition rule, used to calculate two events happening together. How do you calculate? This is the formula. Okay, that's the addition rule. First, you have to do an intersection, and then you have to remove the the end part of it. Now, how that is done? It is a total set theory formula. There is let's say a calculate probability of a union of two events. These are two events, and out of which this is the common event. Can you see my cursor?
Yeah.
We want the result of only out event, but this event should not be repeated. So we want the probability of both the event occurring, that would be event of A plus probability of B minus A intersection B. So we get the whole part, as you can see. Okay. Again, for mutually exclusive event, for odd, what we do? We do a plus B. The event that are happening, that are going to happen mutually. Cool. Any doubt anywhere? Am I going too fast? Do you want me to go slow? Or are we good? Okay. Now there's a multiplication rule used to find probability that two events occur together. Whenever two events occur together, then this is how we do it. For independent events, if A and B, we do a multiplication rule. Example, a event A is rolling a 3 on the first throw of a dice, and event B is rolling an even number on the second throw. Okay, these are independent events. Now, if you want to check the probability of both the event happening, which is rolling a 3 is 1 by 6, rolling a dice which is even number, it is 3 by 6. And if you want to calculate the probability of both the event happening, which is A cross B, 1 by 6 into 3 by 6, that is 1 by 12. It is happening 1, 3, and an even number happening. This total number of outcome is 12, and that is the 1 by 12. Okay. Now for dependent events, that is A and B, this is the formula. P of A and P of B by even I have to understand what is this. Okay. P bar A. Okay. For dependent event, this is the formula. And how does that? Okay, that is okay. Probability of B divided by probability of A. Okay. Okay. A bag contains 5 red balls, 3 blue balls. 2 balls are without replacement. 2 balls are drawn without replacement. Okay. Event A B drawing the first event is that we will be drawing the red ball. Event B that we will be drawing. Okay. Event B drawing a red ball second. These are the two events that you want to take care of. Now there are 5 red balls and there are total 8 balls. So probability of A happening would be 5 out of 8. After removing 1 ball, there are 4 red balls left. So probability of getting red ball would be 4 by 7 because we have reduced the sample space. Now for both the event happening, that would be A and B, that is 5 by 8 into 4 by 7, which is 20 by 16. And hence we have 5 by 14. So probability of drawing 2 red balls without replacement is 5 by 14. So as soon as we remove the ball, we're keeping it together. So we are calculating the sample space, and this is the formula to calculate for the dependent event. Okay. Independent versus dependent events. Okay. The outcome of one event does not affect the other event, tossing 2 points. I mean, the just mentioned. Okay, dependent. One event affects the probability of other event. Drawing 2 cards without replacement. You are getting the example of independent dependent events. Let's say we are drawing a card, the card is already replaced, the sample space get reversed, and hence it does affect the probability. Mutually exclusive event. Two events are mutually exclusive if they cannot happen at the same time. That is rolling a 2 and event B rolling a 5. These are mutually exclusive events. They cannot show both at the one time. It can be either 2 or 5. It can't be 2 and 5 together. Okay. Cool. So what did we cover? We cover complement rule, which is the example that I gave, that there's a win percentage. If you have calculated the win of one team, then the negative of that would be negative by the total outcome would be the win percent of the other team. The addition rule for the unions, no need to memorize it. We will be going into depth in this. Multiplication rule for intersection and understanding independence and exclusivity. Okay. A card is drawn from a standard deck. What is the probability of drawing a red card or a queen card? Do you want to solve it? Okay. If you I mean you guys have pen and paper now. If you can,
Yeah.
if you want to solve it. Let me know when done. Do you want to see the formula for an OR event?
58 by 52. It is coming from I don't know it is either one. But
What is the answer?
28 by 52.
That is correct. Can you explain how it came?
Uh, Probability of A plus probability of B minus probability of A intersection B.
That is correct. Okay. That is the
So
formula for your OR probability.
A be the event of getting red card and B be the event of getting queen, and queen of red is the intersection.
Cool. Anybody any doubt on this? Okay. If two dice are rolled, what is the probability that both show even number? What's the probability for that?
Your screen is not.
Oh, I'm not sharing my screen?
Yeah.
Oh, okay. Okay. If two dice are rolled, what is the probability that both shows even number? I'll paste it in the chat. Media pro.
Three by 36.
What is it?
3 by
If
36.
two dice are rolled, what is the probability both show an even number? Okay, let's what will be the sample space? There are two dice, right? So the sample space would be 6 raised to n, which is 36. Two dice, 6 raised to 2, that is 36. Okay. Total number of outcomes of even number?
Both show even number. So on both the dice.
Both show even
should be
number.
right? That's 2, 2. Okay, my bad. 2, 2, 2, 4, 2, 6.
Okay. So that's the approach that we have used is not the most efficient one. So there are two different events you have to calculate for each dice. One dice, the sample space is 6. It coming even is 3 by 6, that is half. Another dice, the event is coming is 3 by 6. Now this is what is the probability both showing the same event, so we do a multiplication. Okay. Yeah, that would be 1 by 4. So that's the probability. Okay, let's move to theorems. Making this theoretical lectures interesting is a task actually. Those practical lectures where you type codes and all that, it's actually interesting. Writing in Jupyter Notebook, you see an output, everybody's interactive. And yeah, no worries, we'll be getting started with machine learning very soon. Scikit-learn and everything is going to be very cool. And after that, we'll also build our LLM. Maybe it will be a couple of weeks later. Okay, I just wanted the base strong for you guys. So you have all the ideas what exactly is happening behind the scene. Okay, now I'm wondering, should I go through base theorem or should I not? And the theorems that I have are base theorem, binomial distribution, normal distribution, and center limit theorem.
It will
What
take
we
time,
will
I
do,
guess.
sorry?
It will take time, I think.
Yeah, definitely will take time. So what I'll do, what do I see? See, it's a theoretical lecture. So what I'll do, I'll create a note for all of this and I'll share it with you guys. So that would be better. Go through it. It's not something we'll be writing from scratch, but it is definitely good to have knowledge about all of this. So that will do. And let's stop the lecture here. We'll meet in the next lecture. We finish probability here. All the concepts are clear. There is no doubt. I believe all three of you are familiar with probability and how to use it, sample space, events, and everything. Need doubt, do let me know. I'll share all the notes and all the lectures. Please go through it once. That should be more than enough. And we will be getting started with machine learning from the next lecture. That is going to be very interesting. Okay. Okay, cool. Thank you guys. Thank you for your time. See you on Sunday.
Bye.
Okay.
Okay.
Bye.